I'm gonna teach you how to recreate Resident Evil in Godot. I'm talking about the classic tank controls and fixed camera system. It's gonna be so easy, it's gonna blow your mind. I'm even gonna go the extra mile and teach you how to create these cinematic shots inspired by Silent Hill. So without further ado, let's go. Alright, I have a very simple scene with a floor mesh. It has a collision. Let me create a folder for the player stuff. I am going to drag in a 3D model that already has animations and all. Now before I drag this into the scene, let me create a new character body. This is going to be the player. Now I'm going to drag this into the scene as a child of the character body. In my case, the model is looking at the positive z-axis. If we want to avoid any headaches, we can just rotate it 90 degrees. I just held down Control and now we give it a collision shape. And we can go with a capsule, of course. We make it relatively the same size as the model. And I will give this a script that I will put in the player folder called player.gd. Now I want to give this script a class name, call it player. And now we can start working on the movement. I want to create an export group. I will call this movement settings. And I'll create my first export variable. And I'll call this turn speed. I'll set it to a default of 180. And I'll do this because I want it to be a float. We also want a walk speed. 80 was the one I liked the most. A run speed with 280 being what I liked the most. So these are all the variables we need for the basic movement. I'll be using a few functions here just to make it organized. So how do we handle the turn? We need inputs. Turn left and turn right. Move forward and move backward. A, turning left, D for turning right, W for moving forward, S for moving backward. Once we have this, we can create a variable and call this turn direction. And make this equal to input.getAxis, turn left, turn right. So what this is going to do is it's going to give a value from 0 to 1 for each of these, and it's going to give you a value from -1 to 1, and it's going to be 0 most times when you're not pressing anything. So with this value, we can just take our rotation or degrees. This is up to you. Degrees is going to be much slower. I think I used degrees, that's why I used 180. Y minus equals turn direction times turn speed times delta, and we can get delta from a parameter. So we can simply put this in our physics process, handle turn, and pass delta as a parameter. Okay, we can test this. Let's select the current scene as the main scene, and oh, there we go. I always forget to put everything that we need for a 3D scene. Add the sun and the environment to this scene, and oh yeah, we need a camera. That's good, that's good enough. All right. As you can see, we can turn. Next function I'm going to create is a handle walk. And again, I know I'm going to need delta, so I'm already going to get it through here. I want a input direction. And this one is also an axis. From move backward to move forward. We're going to get now a walk velocity. This is very simple. It's going to be equal to negative basis.z. What is this? This is the front of the character, whatever the character is facing. So if I click on the player, this is where basis.z is looking at all times. It follows the blue arrow. So we're going to take this direction and we're going to multiply this by our input. Again, a value from -1 to 1. So this is either going to increase or decrease the value based on input. And then I need the walk speed and delta. Velocity.x. And this comes from the character body class. This velocity right here. I'm sure most of you know that. Walk velocity.x. So I'm just going to do the same for the z-axis. So don't worry about the y-axis right now. Once again, we just handle walk here. Oops. Handle walk delta. And there is one thing though. I'm going to call move and slide in here. This is the function that moves our character based on this velocity. So now I can move and go forwards and backwards. I'm going to create a handle run function called delta. And in essence, it's about the same as walk. So I could just copy paste this, but there is a difference. We don't actually want to run backwards. In Resident Evil games, you can't do that. So if you're going backwards, you don't want to run at all. I'm going to use a different function here. Get action strength. Move forward. Oh my god. Move forward. I might rename this to input strength so it's clear that it's different. And this uses run speed and not walk speed. So this is just a value from 0 to 1, meaning we can't go backwards. But if the player ever presses, this is just a being sure that you can't ever run backwards. If the player ever presses S, we just want to handle walk and then return. Return is obviously going to prevent anything else from running. So if the player ever presses the S key, we're not going to run. Now we also need an input for running. So call it run. And in my case, I'd like it to be the shift key. If input.isAction pressed run, we handle run, else we handle walk. Now we can hold down shift and run. We cannot run backwards. Gravity is quite simple. I want a constant value here for gravity. And I'll say that it's negative 9.81. You guessed it, I'm going to create a function called handle gravity. Also, I will need delta here. This function is actually the simplest. If the player is on floor, we want to set the velocity.y to be 0 or -2 in my case, because I like it to the player to fall a little faster when they are not on the floor. But if they are not on the floor, you do want to then calculate gravity, which is velocity.y plus equals gravity times delta. Just before move and slide, we will handle gravity. And I like to make sure that gravity is working. I'll take a rigid body, find a mesh for it because I want to see it in the game. So I'll put this rigid body right next to the player. I'll make sure their bottom parts are aligned. And the rigid body, for those of you who don't know, is calculating physics automatically. I'll turn on physics interpolation because I want things to feel a little smoother. And yep. It works. I can get rid of this cube now, like I do get rid of most cubes. It falls. It runs. It walks backwards. If you're wondering how to escape tutorial hell and stop needing tutorials like this to create your own game systems, like I did for this one, the process involves a lot of trial and error and tinkering with code. That's why I highly recommend Brilliant. I've used their product and it's amazing. You get hands-on learning through these courses that are step-by-step interactive lessons, and they are personalized to you. You actually learn by doing, which is what I just told you to do. All the courses are crafted by world-class teachers from MIT, Harvard, and Stanford. And the main appeal is that they are fun. Specifically, I like the Thinking in Code course because, you know, that skill will translate to everything in game development. You're gonna solve the problems and train your brain to think like a program. I seriously can't recommend Brilliant enough, and if you want to learn for free on Brilliant for a full 30 days, go to brilliant.org/Freddy. Scan the QR code on the screen or click the link in the description. Brilliant has also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thank you so much for sponsoring this video, Brilliant. Now let's get back to the tutorial. So I was here in the middle of animation and I totally forgot about quick turning. Also not the easiest, but I'll do my best to explain it. So we need a quick turn speed. I set mine to 0.3. This is actually in seconds. I'll do a little tooltip here that says this is the time it takes to quick turn in seconds. So with this, we can hover over this and it shows us what we just wrote. I'm also going to create a variable, and probably do this at the end, is quick turning. And this is a boolean that is false by default. We also need a button that we would like to use for quick turn. I will use Q. I'm going to use the input function or unhandled inputs. If input is action just pressed, so this is just pressed because it's only once, quick turn. And we are not currently quick turning, so we can't spam. We will call a function here. This is optional. You could just write everything inside this, but I like to keep it organized within simple functions. First thing we do is we set isQuickTurning to true. Now we create a target Y rotation, and this could be rotation degrees, our current rotation degrees, .y plus 180 degrees, of course. Or if you want to keep everything in radians, rotation.y plus pi. Okay, in theory, if we set our rotation to this target rotation, this is enough, right? So we just call quick turn in here, and if we play the game, as you saw, it's instant. So how do we make it not instant? Well, there are a few ways. You could use a lerp angle function that would linearly interpolate this, but then you would have to call this in process, and it would be a whole thing. And I'm just going to use a tweener. So var tween is a create tween as tween. Now, tween is a special class in Godot that creates these little animations for you through code. It is useful for certain things, very dangerous for other things, but I genuinely think in this case it's alright if we use tweens, tween property. And the first parameter is the object that we want to be controlling. It's self because it's the player. Then the property, which is rotation, but not just rotation. It's rotation Y, right? But in order to do that, we do a colon Y. Then we set that to the target rotation. And then we need a time. And that's our quick turn time variable or quick turn speed variable that we had earlier. Quick turn speed. Thought that was a little slow, so I'm going to go with 0.2. And now a very subtle thing is we need to set isQuickTurning back to false. So the tween has a signal called finished that we can connect to. And I'm going to connect to a lambda. So a lambda is just a function that is written in here. So we're creating a new function here essentially because it's only one line, right? So I just want to set QuickTurning to false. So I'm not going to create a whole function outside of this. So a lambda works just fine. So whenever the tween is finished animating, this is going to set QuickTurning back to false. So now I can kind of spam it, but it's going to wait for the entire animation to finish at least. And there it is. Also, when you run and you quick turn, this thing happens. You're going to do a weird motion that doesn't happen in the Resident Evil games. To fix this, if is quick turning, we want to set velocity.x to 0 and velocity.y or .z, sorry, not y, please, to 0. This is going to make sense when we cover aiming, but for now, all you need to know is that the weird motion no longer happens. We're simply quick turning very smoothly. So now let's talk about aiming. If I click on my player model right here, in fact, I'm going to rename this to model. If I click on it and enable editable children, you're going to notice there's an animation player here because I took care of the animations in Blender. I'm going to go for the idle animation and set it to auto load or auto play on load. And now when I play the game, you can see that he is playing the idle animation. I'm just going to do a bonus section here that you can skip where I talk about animations and how they are so simple for this kind of game. You literally only need an idle, run, walk back, and aim. You need nothing else. I'll create an export group. I'll call it animation settings or something. I don't know. I'm not very creative for this type of thing. For the animation, we need animation player and default blend time. And now you might have guessed it. I'm going to create a function so we can handle animation in it. Now, would I do this in a real game? Absolutely not. I'm doing everything within a single script for the video. I would use a state machine. I highly recommend you to find out what a state machine is and use it for this game, because then you could just call the proper animation for the proper state the player is currently in. And you wouldn't need this function at all, and you wouldn't need to go through this trouble. And you would just save yourself a lot of headache. Okay? And this is surprisingly complex without a state machine. I will create an input vector. Now, don't be scared by this. I assure you, this is absolutely necessary. Input vector is going to create a vector 2 with the x-axis being left and right and the y-axis being up. And if it's 0, we instantly play the idle animation. And in comes the part that we talk about all the run and walk animations. There it is. Okay, so if the forwards and backwards axis is bigger than 0, we're going to either play the run or the walk animation. And this is for in the walk back animation. So if the input vector is less than 0, and this is just like a dead zone for the controller, not to freak out, then we can play the walk back animation. And this is for the turning. Okay, so if we're turning, we play the walk animation as well. I'll call it after everything. Playing the backwards animation. Stops playing when we quick turn so it doesn't look weird. And play the run animation. You see that everything's using the default blend time, right? Anyway, that's animations. Now back to aiming. Okay, for aiming, I am going to create a isAiming variable. Again, this just wouldn't be necessary if we had a state machine. But for the sake of this tutorial, I'm not going to create a state machine. I'm going to do everything the old way. I highly recommend you do use a state machine. So for aiming, it's just a matter of playing the aim animation. I'll create a input for this called aim. I will do the right mouse button, and the isAiming variable is going to be defined in the physics process. IsAiming is going to be equal to input isAction pressed. Oh my god. Aim. If we are quick turning or aiming, we don't want to move. If we are aiming, just play the aim animation and then don't do anything else for the rest of this function. Okay, so now I'm aiming. And just like the classic Resident Evil, this is how aiming works. Now let's talk about the camera system. As I said, we have a few different types of cameras. We have a fixed camera. We have the camera that can follow the player, like look at the player, and a rail camera. Okay, so I've created this with the CSG nodes, and now we want the cameras to change so we can see the rest of the level, right? This is what the level looks like. It's just two hallways. So let's create our cameras. You know what? I'll just call it RE camera. Why not? I'm not very good with names. Give it a better name. All we need is an export follow player. This is just a Boolean. It's going to be false. We want player. This is a type player. It's going to be null by default. I will explain this in a second. Now, in our physics process, let's take care of the following player thing. If follow player is checked and there is a player, we look at player.global position. So this is it for the camera that follows the player. This is the whole functionality. Now let's talk about changing cameras, because that's important. So I'm going to click here and I will put a area 3D in here. I'm also going to go ahead and create a layer. It doesn't have to be in any layer because nothing will detect this area, but this area will detect, I don't know, layer 3 might be this. We can also change the layer names, so I'll just say that layer 3 from now on is the camera triggers. And important as well is the player should now be in layer 3 as well here. So now this area can only detect the player. We're going to worry about the collision shape individually for each one, so I'll talk about it later. I might rename this to trigger, just so it's clear. Right about here, you're going to find signals. And body entered is the one we're looking for. So we connect this to the camera. If body is player, we will set our player to be the body. Okay, so this variable now has a value. It's the player. But more important than that, we set current. Oh my god. We set current to true. And funnily enough, this will already switch the camera for us because there can only be one current camera in each viewport. So as long as all your cameras are in the same viewport, this code works. Now, if you have the necessity of multiple viewports, you could create a group, a global group for cameras, and I might as well just do this, set it to global, and every camera will be here. And then instead of saying this, or before saying this, you say, what you gotta do is for camera in, right? So this is going to do it for all cameras. You do camera.current equals false. Okay, so this is all you got to do if you need to have multiple viewports. You would need to consider a bunch of things when using multiple viewports anyway. You might as well just use a single viewport for all of these cameras. So maybe you don't believe me, but this takes care of both of these camera types already. So we don't have to do anything else. What we got to do now is take this camera and save this as a scene. So I'm going to save this in the player stuff. Now I can just drag and drop multiple cameras. But don't forget, they all need a collision shape. So you have to click Edible Children. And for each individual one, you have to provide a different collision shape. Collision shape for this one, it can be a simple box. And this is where, when the player walks through this area, it's going to switch to this camera. All right. This area, I want it to switch to this camera when the player is around here. So just extend this. There it is. So this is the trigger for this camera. Okay. Now I can drag in another camera, and this one's going to be here in the corner. I want this to be like a security cam, right? Edible Children. Create a new collision shape, a new box shape. You're going to find a bug. We're going to find a bug here together. Okay. It's something that you have to be careful about. And also, if the player is coming from the other side, I also want it to trigger. So I'll put make it a little bigger, right? From each side of this hallway, the player can, oh my God, what am I doing? The player can trigger this cam. Okay. Now let's find the bug together, shall we? I will play this. Here's the first cam. I triggered the second camera. I forgot to check follow player. This is all we got to do. So we triggered the second camera. Oh, good. We're following the player. Awesome. Now we trigger the first. Good. Now. Uh-oh. What happened? No more. So if we turn on visible collision shapes. So we're here. We're seeing all the collision shapes. You can see the second box right there. But when it's gone. As soon as I touched it, it's gone. What's happening? The camera is moving, which is in turn moving the collision shape. Collision shape is being moved together with the camera. How do we fix this? It's simple. Go to the actual scene of the camera, click on the trigger, go to transform, set it to top level. So this is going to make sure that the trigger is not influenced by the camera's movement. So now we trigger it, and there it is. There's the box. It stays in the same place. No problemo. I'm actually going to duplicate this, make this unique. Don't forget to do this if you duplicate cameras ever. So this is what it looks like. One camera following the player here. One camera following the player here. All fine and dandy. And now for the last type of camera, a rail camera. Okay, so the rail camera is a new type. Let me create it here. It's another node. It's a path 3D. Let's call this rail camera. I'm going to save this here in the player as well. Now we need a path follow 3D. And we're going to duplicate our camera here. Okay. Now follow player is optional again. Sometimes you want this to follow the player. Sometimes you don't want that to happen. So give the rail camera a script. We're going to go ahead and get a reference to the camera. Now we want to get, in the process or physics process, we want to get the player. Okay, we need the player's position. So if camera.player, this is going to check if the camera has a player. You could be verbose and say if not equals null, like this. Player position is what we need. So equals camera.player.global position. We're going to go ahead and get our path follow. I'm going to explain this in a second. Okay. Progress equals, and we're going to get our curve, current curve, get closest offset. This is the function we need. Player position. Okay. I swear to God, this is all the code we need. Now let's worry about let's assign the camera first. Let's worry about what a rail camera is. How are we going to do this? So a path 3D is a simple node. Okay. You create a curve. A path follow is going to use this progress to go across the curve. Okay, let's see this in action. I'm going to go to this hallway right here, and I'm going to put a follow camera, or a rail camera, sorry. I'm going to put a rail camera right here, kind of in the middle of the hallway. I'm going to turn on editable children, because for this specific case, I want to change the camera's default settings, but I'll do it in a second. How do you do this? How do you create a path for the camera to follow? I like to do this in a orthogonal view. The workflow is simple. Click this to add new points and add point A, point B, and you're done. If we look at it from 3D view, you see there's a green path. Now you can have as many as you want, as many points as you want, but a straight line is going to be awesome for us right now. You can always click on the camera and do whatever you want with the camera. It's going to follow from the offset that you put it here. The world is your oyster, my friend. This is truly magnificent. So I want the camera to be quite low, right? And I want it to start kind of right here and look at the player from this angle, right? Now remember, this one also needs a trigger. Collision, shape, box shape, and yeah, I just want it to be here. Here's good, right at the end of the other one. Try not to let the triggers overlap each other. You also want to turn off loop. Forgot about this. Because if you leave loop turned on, the camera is going to go back. You just don't want this in this case, okay? Okay. So it needed to be farther away than I thought. But here it is. And man, I love this type of camera. Follows the player through a hallway. And you know what's crazy? We could even take this. If you click on tilt handles, that's where you can actually tilt this a little bit and create a weird effect. I have no idea how that's going to look. If I'm being honest, I never tried this. I really just tested the... Oh my god. Okay, yeah. I guess we learned that we have to be careful with tilting. Let's see if that looks less weird. Oh, see, this is what I'm talking about. Oh yes, this looks so good, bro. Oh my god. Now it's a bit random because I couldn't make it perfect. But if you can get the hang of this, bro, can you create some amazing shit? Yeah. And let me know if you want a part 2 where I talk about auto aiming and the rest of the combat system. See ya.